our z again. This time we are going to multiply, we are going to divide by our dy, then we'll also multiply it by changes in our y. Are we there?
Let's go.
Yes. So this is the first thing you should do. This is the first thing you should do. Okay. So the next one is to now differentiate. This one is telling you that we are going to differentiate with respect to x. This one is also telling you that we are going to differentiate with respect to our y. So let's differentiate with respect to x. Don't forget your differentiation. Oh. So if we are going to differentiate with respect to x, we are going to get so our dz over the x is going to give us, here we are going to get 12x minus 0.3 xy. Sorry, 0.3 y. (0.3y). Then our dz over our dy. So here we are differentiating respect to y. The first one we're differentiating respect to x. So then the next one we're going to differentiate respect to our y. So we are going to get differentiate this one respect to y. We are going to get 16. We are going to get 16y 16y minus 0.3x. Please, are you following?
Yes, sir.
Yes, sir.
Yes, so that's how we do the differentiation. So what we'll do next is, we know our dz dx, we know our dz dy. So we substitute them into this formula. We substitute them here. And that is our total differential. That will be our total differential. So we'll look at wherever we see dz dx, we'll put this differential there. So our dz is equal to, the first differential is 12. Dz dx is 12x. If 12x equals 0.3 y multiplied by our changes in x. So changes in x. Changes in x plus another one, that is our dz dy. Dz dy is 16 minus 0.3x.
It's 61.
Then you close the bracket.
Dr.
Close the bracket. Then you multiply. Yes, 6y. Sorry. So let me write it here. It's 16y minus 0.3x. Then you multiply by changes in our y. So this is all about the total differential. So some instances they will give you the value of changes in x. and the value of changes in y. So let's assume that if they say changes in x is equal to 2, and then changes in y is equal to 1. So sometimes they can give you these scenarios so that when you find your total changes, wherever you see 2, you get substitute the 2 and the 1 there, then you get your total differential. So this is all about the total differential we are talking about. It's not something difficult. Any confusing? Okay. So if there's no question, let's move on to the next example. Let's see if we have another example. Yes, so this is another example. This is another example. So here, let me go back to let me copy it and go back to the board. Go back to the board, this place. Then I will rub this one. I will clean this one off. Then I'll paste. Oh, I'll paste this one so that we'll look at how to do the total differential for this. Okay. So the formula is clear. So we are giving, let's say this one, can we say a saving function? Yes. Saving function or investment function, where our savings depends on our income and interest rate, or our investment depend on income and interest rate. So we can find the total differential here. So what we are going to do is that we are going to look at the formula. So here, the main dependent variable is S. So we look at the X. The X. So the S will be equal to, so we are going to differentiate the S with respect to each of the variables, Y and I. So the partial differential of X. So we have this S, sorry. So we have our, this. So our S here. Then we divide by, what's my pen like that? Okay. So we divide by our first one is Y. So divide by the Y. Then we multiply by changes in Y. Then plus, and then here again, we are going to look at X with respect to our I. Our I. Then we multiply here by our changes in I. Changes in I. So if you are able to do this, then the rest is just to differentiate this one with respect to Y, and also differentiate it with respect to our I. So let's look for the S over the Y. the x over the y. Let's look for the x over the y. So if we differentiate s respect to y, this is our y column. What are we going to get? Who can tell me?
It's going to be half.
Yes, it's going to be half. So differentiate this one, you are going to get 1 over 2. Then we also differentiate s. We'll also differentiate our ds over our di. What are we getting for that?
3.
Yes, sir.
We are going to get 3. So we have done the
We get
differential. So what we are going to do is that, yes, we are going to get 3. So what we are going to do is that we are going to replace them into the function. We are going to replace them into the function so that wherever we see our the s over the y is going to be half. So it's going to be the final answer is going to be this s to be equal to ds dy, which is half. So 1 over 2 multiplied by changes in y. So the changes in y is not given. So you write it changes in y. Changes in y. So plus this s di is going to give you 3. So it's going to be 3 2, and then multiply by changes in what I. And that is all about the total differential. So now the most difficult part here is that, see, we are giving you a simple equations. That's why you are able to get it like, yes, able to get everything on point. There will be a time that, remember that we have type of differentiation. We have the product rule, we have the chain rule, we have the quotient rule, and the rest. So if they are given to you in terms of fraction, the functions are in a fraction form, the functions are in product rule form, that is where the difficulties come by. But the formula is going to be the same, but how we are going to manipulate using the type of functions. So take note of the type of function they will give it to you. So take note of the type of function they are going to give to you. It's very, very important to determine what you are going to do next. Okay. Let's see. Yes, so like this function here, this function given here. You see that what type of function is this? Which formula are we using when we are going to differentiate? Is it the product rule or the quotient rule or the chain rule? Yes. If you are giving something like this, which formula are you using? Hey, nobody can tell me. Hello.
Hello, sir.
Yes. So if our function is in the fraction form, which of the approach are we using in terms of differentiation? Okay. It's like you don't want to speak. Okay. This is a
We have forgotten.
Oh, dog.
so
It
this
should be the
Hello.
product rule.
You would want to disappoint
Yes.
me. You have to talk.
Hey,
I think the chain rule will do.
chain rule.
Yes, sir.
Yes, who else want to try?
I said the product rule.
The product rule. Okay, you are right. I think you are right than I do.
You say you are right. The word product will tell you something. When we say product, what would the functions look like?
Because I was in.
When we say product, what does it mean? Take the product of two numbers.
We are
Multiply.
multiplying.
Yes, so
Multiplying.
is this function a multiplication function?
No.
This one is a division function. You are dividing a function by a function. So this is the quotient rule.
Question.
We use quotient rule.
Terms, no, we are confused about the terms.
Yeah, this is the quotient rule.
Yeah.
So let's copy it and then go and see how we are going to do it. So, like I said, the total differential is simple, but the type of function that will be given to you will make it complex for you. But the approach itself is not anything. So I'm just going to copy it there. Then we see how we can solve it. Okay, so we have it here. We have it here. So what is the first thing we should do? We should be able to define this in terms of the total differential rule. So here, how many variables are there? How many variables are we dealing with?
Two.
Two variables, yes. So we are looking at x1 and x2. These are the two variables. So we are going to look at total changes in y. So our dy is there. So we should have our dy to be equal to, we differentiate our dy, our y, with respect to what? X1. Then we multiply by changes in x1. Then we'll add it to the differential of y with respect to x2. And then we'll multiply by changes in x2. After this, I'm going to give you an example for you to try.
Doc, I think I know for sure everybody is silent on this issue, but it is something that we have to raise first. About the,
Yes, go ahead.
about the changes in y, x, y. No? How do we determine that before you multiply with
About changes in
x, y? Or that is, yeah.
changes in xy. Where's changes in xy?
No.
The one you are multiplying, changes in S line.
How do we determine that?
This,
Yes.
the one that cycle.
Yes. How do
Yes,
you
yes,
determine that one first?
Yes, so like I gave, like maybe you were skeptical because I said that when I was doing the first one, I said sometimes they will give you the value of x changes in x.
Okay.
I don't know whether you remember or not.
That's why I want to, yeah.
So they will give you, if they want you to compete the total differential in terms of values, they will give you the value for changes in x.
Okay.
They also give you the value for changes in x2 and x1.
Okay.
So you can also substitute them in. So those changes are being determined by the questions. So with this one, they can ask you to find the total differential, where I think there's an example there where changes in x, you can say where changes in x1 is equal to 2. Changes in x2 is equal to 3. So if they do this, then they are giving you the value of change in x1, x2. So after you have done everything, then you now come and substitute the x1, which is equal to 2, x3, which is x1 is equal to 2, and then changes in x2, which is equal to 3, into the final answer you've gotten. So this will be determined by the question. So it will be given to you.
Thank you very much.
I hope you are okay.
Yeah.
All right. So with this, we are now coming to differentiate with respect to x1. So we have our let's differentiate with respect to x1. So we have our dy over our dx1. And you have to remember the rules, the quotient rule. How do we do the quotient rule? Who can remember brief? How do we do the quotient rule? So what do you do? The quotient rule is that, please, you have to go and then we did this last block or last semester or last semester. What you do is that you have to hold this one constant. So let's say the down one is our, let's say v. Let's say v. This one is our u. Okay. So to apply the quotient rule, then it's going to be v. You have to hold the v constant. You don't differentiate the v. So hold the v constant. Then you differentiate the u. So it's going to be the u over the x. Then plus, this time, sorry, it's not plus, it's minus. So minus, this time around, you are going to hold the u constant. So you hold the u and you differentiate the v. So the v over the x. Then you divide all by what? V squared. We did this last semester. This is the formula for the quotient rule. This is the formula for the quotient rule. Okay. So that is what we are going to do here. We are going to apply the quotient to do the differential. So let me take this off once we now know the approach. So first, we are holding the V constant. So we are holding the denominator constant. So let's write it as it is. So we have our 2x1 squared. Then we are going to multiply this one by the differential of x, the denominator, this one. We now differentiate our up with respect to x1. Remember, we are dealing with x1 first. So if you differentiate the up with respect to x1, what are we getting? Hello?
Yes, sir.
We are holding the down one constant. That is what I've written it. We are not taking that one. But we are going to differentiate the up one with respect to one. With respect to x1. So let's differentiate the up one with respect to x1. What are we getting?
We'll get x2.
So that will give us 4s1.
Sorry, we are not differentiating the down one. We are differentiating only the up one with respect to x1.
So we'll get s2.
No. Come again.
So we are going to get 2x.
Come again. We are not differentiating the down. We are differentiating the up. Because the quotient rule say that you have to hold the you have to hold the down. You have to hold the down constant and you differentiate the up one first. So we are differentiating only the up one.
Then we'll get x2 over 2x 2x1 squared.
Oh, you are going far. You
Sorry.
see, we are not differentiating, we are not considering the down one, that is 2x1 squared. We are not considering that. We are considering only the up. And with the up, we are differentiating only x1.
Something minus something like that.
Oh. So if we have, let me say, y is equal to x plus y. This is the same thing, x plus y. And we are going to differentiate with respect to x. What are we getting?
You get y.
You get y. Okay, so what about this? You different this y is equal to x y. What is the difference between the two?
The second one is the product.
So if we differentiate the second one, what are you going to get?
You get y.
What about the first one? The first one was what?
Y minus x or so.
Okay. You see, x here and y here are different functions. You see, the plus is differentiating them. These are all different functions from each other. X is different from Y because of the sign here. The plus here is differentiating the two from each other. But here they are together. They cannot do with each other. So if we are differentiating X, we are going to get Y. If you are differentiating Y, you are going to get X. But here they are not together. They are separate. They are different variables separated by this operation plus. So they are not together. So if you differentiate, so the second, you say if you differentiate for the second one, if you differentiate X, you are going to get Y. We are saying Y because if you differentiate the X itself, we are going to get 1. And you multiply the 1 by the Y to get the Y. So here, if you differentiate the X here, you are going to get 1. This one and this one is different functions. They are not together. Oh.
Abefa, what do you?
So let's go. So if you differentiate the upper one, you are going to get 1. So you are going to get 1 here. Then minus, again, the first one, we held the down one constant and we differentiated the up one. Now we are going to hold the up one constant and differentiate the down. So holding the up one constant, we are going to get our x1 plus x2. Now we are going to differentiate our down one. Differentiating the down one, we are going to get, what are we going to get? Differentiating 2x1 squared.
4x.
We are going to get what?
4x.
Yes, so you are going to get 4x1. 4x1. Then remember the formula was to divide all by v squared. So here you are going to divide here by our v squared. What is our v squared? The v is our 2x squared. So we are going to get our 2x1 all over all squared. All squared. Now remember, this is for only x1. X1. We'll do the same for x2. So let's simplify this. Let's simplify this. So if we are going to simplify this, we are going to open this bracket. Multiply this one by this, you are going to get your 2. You are going to get 2x1 squared. Then you open this bracket as well. You are going to get let's open this bracket. We are going to get our 4x. This one is going to multiply by this. So we are going to get minus 4x. Minus 4x squared. And then this one too is going to multiply by this. So we are going to get minus 4x 1 x 2. So this one is multiplying by this. So x4 x1 x2. So this is what we are going to get for all of this. Then we divide it by the down one. The down one is x. The down one is 2x squared, and then there's a square. So the square here is affecting all of them. So it's going to be like this: 2 raised to the power 2, and then x squared raised to the power. The x squared is already 2, so it's going to be 4. So that the x is already raised to the power 2. So it's going to give you 4. So the 2 is multiplying inside. So the down one, you are going to get 4. 2 raised to the power 2 here is 4. So you're going to get 4x1 and then raised to the power 4. So this is what we are going to get. And you can simplify this.
Hello, sir.
Yes.
If you
Go
can
ahead.
go over the down one again. The down one,
down
down
one.
below. Yeah.
Okay. So let me clean this. And clean this one, then go over. So the down one, we are dividing here by our 2x1 squared. And all this one was squared. So this one, because this is in the bracket, this 2 here is affecting all the 2 here and then the 2 squared here. So this one, you can rewrite it as 2, multiply this 2 inside there. So you are going to get 2 squared. Because this 2 is coming to multiply here. You get 2 squared. And then x1, you have 2 there. We have the 2 there, which is x1. We also have another 2 outside, which is coming to multiply it. So over, you put the 2 here again. And that is why we are saying that if 2 squared is going to give you 4, and then this 2 multiplied by this 2 is also going to give you 4. That's why we have the 4x1 and then raised to the power 4. Are you okay?
Yes, sir.
Okay. So you can now move on to simplify this. How can we simplify this? So here, it's going to give us our, so this is x1. We can subtract them, right? This one. So it's like, get like 2 minus 4, or the x, they are all the same. So you are going to get 2 minus 4 is going to give you minus 2. So minus 2x minus 2x1 squared. For the first 2, this first 2. Then minus our 4x1 x2. Okay. Are we okay with it? Hello, are we okay with this? So this one is divided by our 4x. Sorry, our 4x raised to power 4. Okay. Again, we can do something here. We can simplify here again. Okay. So what we are going to do is that this 2 here can cancel 1, 2 here. Can cancel this 4 here. So that we have, so if you cancel this 2 with this 2, we are going to get minus x1. And remember that this is 2 and this is 4. So the 2 here can also cancel 2 here. And that is going to give us 2. Okay, so here will be left with only x1. Because the 2 has cancelled it down to 1. Minus our 4x So again, if you see something like this, let me go back and do it clearly for you, for us to understand. Because if we have this, remember this one was dividing all by 4x cube. The 4x cube affect both the first one and the second one. It's not affecting only this. It's affecting all of them. So here I can write 4x here. 4x1 raised to the power 4. It's going to be like this. It's not affecting only one. It's affecting all of them. It's affecting all of them. So we have to take note of this. So that if I'm doing the division, if I'm canceling, it's going to affect all of them. So this one, the 2 here will cancel this 2 here. I'm going to get minus, and then this 2 here, canceling this 2 here. So the only variable left here is x1. So I have x1 minus, so here, again, here is going to be, here is going to give you, let's come to the second part. We have 4 here. Okay. So this one too, we have 4 here. And we also have 4 here. So this 4 is going to cancel this 4. Right? And remember, this is x1. There's x1 here. This one raised to the power x1. This x1 here will cancel one of the x1 here. We'll cancel one of the x1 here. So here is going to give you x1 raised to the power 3. x1 raised to the power 3. And remember, this one is also canceling this. This one is also canceling this. So we are also going to get here our x1 here. And then if 2 is canceling here, it's going to give you 2 here. It's going to give you 2 here. Okay. So again, we are canceling this. It gets like canceling this one. This is 2, and this is 2, and this is 4. So if you are canceling this here, the down one is going to give you, sorry, let me write this one. Okay. So this one is, let's make it clear for you. This is 2 and this is 4. So it gets telling you that it's going to be 2 divided by 4, because they have the same exponent and they have the same variable. So it gets like dividing this one, but this one will divide itself 1 and divide here 2. So here is gone. Here is going to give you 2x raised to power, yes, 2x raised to power what? So here is going to give you 2, sorry. Here is going to give you 2, because this one will go to itself 1 times, it goes here 2. So it gets like dividing 4 by 2. You are going to get 2. Okay. And then if you come to the other side too, we have 4x1 and then x2. Again, that 4x1 is going to cancel itself 1. That 4x1 is going to cancel 4x raised to the power 4, 3 times. So that's why we have the 4x raised to the power 3 here. 3 here. So at the end, what we are getting for dy is going to be, so here is going to give you, there's nothing here. So it's going to give you our 1 over this 2 here multiplied by 3x multiplied by x squared cube is going to give us 2 x cube. You get to give us 2x cube. So our dy over dx is going to give us this. It's going to give us this. And then that is only for the dy dx. Then you will now go and find the x1.
Sir,
Yes.
2 s1 square canceling 4 s1 square. The negative is not affecting it.
Let me come.
The negative.
It's like things are get scattered here. Let me clean this part.
Okay.
Like things are scattered. So let me clean this part so that we can do it well. Okay. So we're having 2
2x squared, 2x1 squared.
2x squared.
That is 2x1 squared.
2x1 squared.
Yeah.
Minus 4x squared.
4x
4x squared.
squared minus
4x1.
4x1
4x1.
x2,
And
right?
then
This
s,
is what we
s, yeah.
then we divide here by 4 x
x1
raised to the power 4, right?
power 4. Yeah. x1
4x1 is to power 4.
Yeah, 1. Okay. And then we said that this one minus this is going to give you minus 2x1 squared.
minus 2x1 squared.
Then we'll now minus our 4x squared 1 x2,
x2, yeah.
and then this one is divided by 4x
x1 4 to the power 4.
Yeah, 4. Okay, so let's do this way. I think this one will cancel here. It will be 2, right?
So please is 4x1.
No, yes, so this one will cancel, the 2 will cancel itself 1, right?
Yes, sir.
And cancel here 2, right?
2.
Yeah.
Yeah.
That's what yes. So we have 2 here. We have 2 here. Then the next one is, you see, so here the minus is there. So let's take it that way. Then we'll come to the 4 aspect, the 4. Now this 4 here, this 4 here is any number raised to the power 1, any number standing alone is raised to the power 1. So we have 1 here. Okay. It is also telling you that this 4 here can go to this 4, this one. This x raised to the power 1 can go to this 4 here. Okay, so if this one go to this place, this one will also turn to 3. I don't know whether you are getting me. Okay, wait. Let me use this different approach for you to
Separating one, we are separating s from the 4.
Yes. Let me use this approach. Maybe that one will help. Okay, so the first one, let's divide 2 by 2. The up one. Let's divide 2 by 2. So we divide here by -2 and divide here by -2. Let me use that approach so that you get it. So if you divide here by if you divide both sides, the up one by -2, what are we going to get? You see that the 2 will cancel itself, right? So you divide here by 2, divide here by 2. This 2 is going to cancel when we are dividing.
Yeah.
So you are going to get negative 2, negative x1 squared. I say you should divide by negative. Okay.
Yeah.
And then here too. If you divide 4 by 2, what are you going to get? You are going to get 2, right?
Yes, sir.
You are going to get 2. So here you are going to get minus 2 as well. So minus 2 x1 x2. Okay, so and now you now divide it by 4 x1 4. One is any number standard alone is for 1. So yeah. So one of the x squared here is coming to cancel one of them here. So you are going to get minus x1 squared minus. So this x1 is now gone. It is cancelled. But the 2 is affecting this. So you are going to get 2 all over now. Now, if you also divide this x here by 4 here by 2, it's going to give us our 2x raised to the power 3. Because one of the x here has come to cancel one of the x here. So the x here has now reduced to 3. Because of and then this x is gone because it has cancelled the down 1 by 1. And then the 4 here, we divide the 4 here by 2. Divide the 4 here by 2. So at the end, this is what you are going to get for the first one. This is what you are going to get for the first one. Then it is telling you that for your x, this one, let me write it here. For your first x, we are still in x1 now. So for your first x1, we are going to get minus x1 minus 2x 2 over 2x cubed. And you can rewrite this one to be, you can factorize the minus out to get minus bracket x1 plus x2 all over our s. So this is what you are going to get for the first x1. Then you now come and do for the x2. Now come and do for the x2. So the x2 here, where's the formula? Okay, so here we did for the x1. So we're now coming to do for the x2. So the x2, remember that we are going to look at dy over the x2. Dy over the x2. Dy over the x2. So what are we going to get?
Hello, sir.
Yeah.
Sir, please kindly draw one Emmanuel's attention. His mic is on, and we are getting a feedback from him. Thank you, sir. Mr. Emmanuel, his microphone is on.
Hello, Ima, can you mute yourself? Okay. Today you are only 13. What happened? Yes, Eric.
Sir,
Yes.
when you are doing factorization, the negative out,
Yes.
it should be S1 plus 2S2.
Oh, yes. So the two should be here. Yes. So, yes. Okay. Thank you for the update. Okay. So with this again, let's now move to the X2. So X2 here, we are now differentiating respect to our X2. First, again, we are going to hold our, yes, Eric, again, your hand is up. Or is the previous one? Okay. So here again, we are going to hold the denominator constant and then differentiate the upbound respect to what? X2. Remember, we differentiated respect to X1 for the first time. So let's hold it constant. We are going to get 2x squared. Then we'll hold our, we are holding it constant and we differentiate respect to X2. We are going to get 1. We're going to get 1. Then we'll minus, now we are going to hold our up 1 constant, X1 plus X2 constant. Sorry. Yes, X2 constant. X1 plus X2 constant. Then we'll now differentiate the down one. So we differentiate the down one, we are going to get 4x. So 4x 4x1, yes, 4x1. And then we divide through by we divide through by our down one squared. So it's going to be the same thing as what we did. So divide through by our x1 squared, all over squared. And then we'll now open the bracket again. So if you're going to open the bracket, okay. So if we are going to open the bracket, we are going to get 2x squared, 2x1 squared minus, so this one is going to multiply this. We are going to get 4x squared. Then this one is going to multiply this minus 4x minus 4x minus 4x keep. Sorry, minus x4x1 x2. And then you divide here all by our 4x squared. No, 4x cube. 4x cube. Okay. So it gets like we are going to get the same similar thing. So here we are going to get this one. Let's divide through by 2 again. We divide through by 2. We are going to get okay. So first of all, this one minus this, we are going to get our negative 2x squared, and this one is going to give us minus 4x x1
Negative 2s1 squared.
negative 2
S, you did not bring the one, the s1. Negative 2s1
negative 2x1 squared
squared.
minus 4x1 x2, and then 4x1 x2. So my space is going to worry me. So let me clean here. So we are going to get negative 2x1 square minus
4x1
x1
s squared
x2
s2,
then
yeah.
divided by 4x1 raised to the power 4. Okay. So this one again, if you are going to divide both sides, you are going to divide through by 2, here by 2, here by 2, here by 2. We are going to get our x1 minus x1 minus 2x1 x2 all over 4 all over 4 okay all over, I'm coming just a minute. Oh,
The wrong thing.
sorry. I think we have made a mistake here. I'm coming. We have made a mistake here. Because we cannot get the same thing. Sorry. I even forgot it. So with the second one, let me explain this. You see, the first one, how we had the answer was because we are differentiating a variable x1. X1 was found in the up one. X1 was also found in the down one. That was why we were using the quotient rule. But the second one, there's no x2 down. It's only x1. And we are differentiating with respect to our x1, our x2. So there's no way we can use the quotient rule. Sorry, I should have clarified this. But the first one, we have x1 up there. We have x1 2 in the down one. So we can use the quotient rule. But with the second one, x2 is up, but there's no x2 down there. So we cannot use the quotient rule. We just use our normal differentiation to do it. I don't know whether you are getting me. Hello?
Hello, sir.
Yes, I'm saying that with the first one, we differentiated.
Yes.
We had x1 down up there, and we also have x1 down.
Down.
So it was good for you to use the quotient rule. But the second differential that we are going to differentiate with respect to our S2, we have S2 up there, but we don't have the S2 down.
Okay.
So we cannot use the quotient rule. We just have to do the normal differentiation and go away. That's all. So with the differentiating y with respect to x or S2, it's just going to give us, when you differentiate this one with respect to S2, we are going to get 1. So it's just going to give a 1 over 2x squared. That's all. This is what we are going to get for the other one, the S1, the S2.
Teshi, meet your mic.
So this is what we are supposed to get for the S2. And then we differentiated the S1. That one was fine because there was S1 up and S1 down. So we needed to use the quotient rule. But the second one, there's no S1 up and down. So we cannot use the quotient rule. We use the normal differentiation. So if we differentiate S2 with respect to S2 itself, we are going to get 1. And then 1 is divided by what? 2s squared. So this is what we are supposed to get, not the other one round. Okay. So if we are able to get that, remember the S1 we differentiated. The S1 we differentiated was respect to X1. We differentiated was minus X1 plus 2x2 all over 2x raised to power q. This is what we get for the X1 and X2. Now we are now coming to use the formula that we did earlier. You don't forget the formula for the total differential. The formula for the total differential is our dy is equal to our differential of y respect to x1 1 multiplied by changes in x1 plus our differential of y respect to x2 multiplied by changes in x2. So now we know our differential of y respect to x2 is this one. So we get substitute them inside. So we are going to get our dy dx1, which is equal to this. So we are going to get our minus bracket x1 plus 2x2 all over our 2x1 raised to power 3 multiplying by the changes in x. So multiply by change in x1. Change in x1 plus we'll now move to the x2. We'll now move to this part. So dy dx2 is going to give you half over. So it's going to give you 2 over 2x cube. And then we'll multiply this one by changes in our x2. Changes in our x2. Okay. So this is the total differential that we are going to get for. So this one will give you our total differential for that formula here. So like I was saying earlier on, the differential itself is not a problem, but the constant that they are going to give you will be the problem. Will be the problem for you. Okay. So this is what we are going to get at the end.
Please, can so
Come again.
Yeah, I'm copying what you just saw.
Oh, okay. Let me know if you are done.
Hello, sir.
Yeah.
Please, is it 1 over 2s square or 1 over 2s 1 square?
It's 1 over 2 1 x squared.
Oh, okay. Then you omitted the 1 over there. The upwards one. 1 over 2 is 1.
Which one?
The upwards. The one. Yeah,
This one.
that one. Yeah.
It's fine.
Okay, Doctor, I'm done.
Okay. So if you are done, then we can move on to the next one. So there are more examples. So look at this example here. The second one, the A. So we can see that they say to find the total differential of this function. Then they are giving you that when x is equal to 1 and y is equal to 2, y is equal to 3, then they are also giving you that changes in the dx is equal to 0.01 and then dy is equal to 0.02. See that they have given you all the values. So when you just calculate them and put the values in there and you are gone. Okay. Do we need to go through the examples? Huh? Hello?
Sir,
Do we need to go
we
through
can,
the example?
no, we can go through and get it.
Okay. So the first example is okay, so let me go to my board. Let me add another board here. And then let me see where's the question. So this is the question. Okay, so this is the question. So let's go through it and see. So first of all, we need to calculate our dz. So our dz, so we are going to get our formula first. Is equal to, we differentiate, so dz. So we are going to get our dz all over all over, we have x and y, so all over, we differentiate with respect to x. Then we multiply here by dx. Please take note. Let me note to here. Note that changes the x is the same, is equal to the y. Sorry, it's equal to the x. So whenever you see, if I'm replacing the chain or the box, this one, if I'm replacing this one with this, don't be surprised, they are all the same. This and this are all the same, so please take note. So this one and the other one have been using the same thing. So plus, go to the y aspect and differentiate with respect to y. So we are going to get this, then multiply by our dy. Our dy. So yeah, let's differentiate with respect to our x. So we have our dz over the x. What are we going to get? 31, 3 multiplied by 9 is going to give you
27.
Come again.
27.
27.
27, sir.
So 27
27x.
s cube or s squared. Yes, s squared. Then minus, we are going to get 16y. So we are going to get 16 x squared s squared. Then plus our 16. Oh, sorry. The last one is y for y. So we are not interested in y. We are interested in only x. So we differentiate the first one and the second one. That's all. So we are going to get 16. Oh, what is happening to my pen? We are going to get minus Yes. X. So we differentiate with respect to only X. We are interested in the only X for the first part. Then the second part, we differentiate with respect to our Y. So dy, we are differentiating this one with respect to Y. So the first one is out, because there's no Y there. So the second one, we are going to differentiate with respect to Y. We are going to get minus, we're going to get minus 8x squared. But when you differentiate this one, the Y will go away. Okay. Then plus, we differentiate this one, we are going to get 16y squared. 16y squared. Please, are you following with the differentiation?
Yes, sir.
Yes. So after the differentiation, then we now come and substitute them into the formula. And the formula is this one. So our dz now is equal to dz dx, which is equal to this. The dz dz is equal to 27 x squared minus 16.
Hello, sir.
Yes.
The 4y cube. The 4y cube. It should be
4y.
Yeah,
Yeah, 4y cube.
3 times 4. It should be 12 rather. It should be 12. Yeah, but you made it 16.
Sorry,
Yeah.
12.
Yeah.
Yes. It's 12. So it should be 12. Okay. So we have 16 xy. And remember, this is multiplied by the changes in x. So the x plus the second one is minus 8x squared plus 12 y cube squared. And remember, this is also multiplying by our dy, just as it is in the formula. Okay. So then if we know this one, the next step is that we are going to, they are giving the value of y, we are giving the value of x, they are giving the value of dy dx. So just substitute them inside the formula, and you get your final answer. So our dy, our dz is equal to, open the bracket, 27. The value of x is given to be what? X is given to be 1.
1.
Can we see? Yes, so we put the 1 there. Then minus 1 squared, sorry, it's 27 squared 1. So we have it there. Minus 16. And then the 16 is multiplied by x and y. So x is 1. And y is what? 3. So y is 3. So we put it there. The whole of this one is plus. The next one is minus 18. Minus 8. And then multiply by 1 squared. Then plus.
So you left. Hello, sir.
Yes.
You left the x 0.01 changes in the x.
Okay. So let me come here.
So 3.
Yes, change in the x is
Yeah.
what? 0.01.
0,
So
1. Yeah.
so you also multiply this one by 0.01. Yes. Then you now add it to the last part, which is our minus 8 bracket 1 squared, then plus 12 bracket y is 3 raised to power this. They multiply by dy. dy is 0
Yeah. 0.02.
minus 0 point. Is it minus? Yes,
Yeah. Yeah. Minus,
minus.
minus 0.02.
minus 0.02. Okay. So you now use your calculator and input it, then you get your final answer. So the total differential is just something that we can do, but when a complex function is given, that is where we always find one, but it's not something that you cannot do. So you can put it in the calculator and give you the final answer.
Okay.
So what did you get? Okay, so if we do it correctly, let's go to the slides. Let's go to the slides. If we do it correctly, we are going to get negative 2.025. Negative 2.025. And what does this mean? The results indicate that an increase of 0.01 in x and a decrease of 0.02 in y when x is equal to 1 and then y is equal to 3 will produce approximately a decrease of 2.05 in the function xy. So these are the marginal changes in the x and y. So if there's a small changes in x and y, it will also have an impact on the function itself. And that is what we call the total differential. Okay. Now let's go to the application. So sometimes we are still under the different total differential, but we can now demonstrate some examples on how the total differential is being applied in economics, especially in production theory. We look at the slope of the isoquant, we look at the slope of the isoquant, and then the marginal rate of technical substitutions. I hope you've done this one in microeconomics, elements and principles. So we are just going to apply the total differential and how we are going to use it. So let's look at the production function. If we are given two output level, so if we are given two output level,
K, any output level or the production of output depend on some input. We always have K and then labor as the main input or as the main input or inputs for the productivity or for the producing the output. If we are having them, and then we can always say that the combination of the input can help us produce a certain level of output. So the combination of input that lead to the production of a certain level of output or the maximum level of output is what we call the isoquant. So the isoquant is a curve showing the combination of different input, capital and labor, to produce the same level of output. So if you have capital and labor, then we can find the slope of this capital and labor. Finding the slope means that we are going to look at the trade-off between the capital and labor. And this also shows that for you to produce more capital, then sometimes you have to reduce the labor input. Or if you want to produce more, if you want to produce using more labor, then you have to make some sacrifices for capital. So that is what we call the marginal rate of technical substitution. We are going to substitute capital for labor or labor for capital. Okay, so our aim is to find for the marginal rate of substitution here, which is the isoquant. Now, with the production function, we know that we use capital and labor to produce the total output. So if we are given capital and labor, we can use the total differential to look at how to also get the total output, changes in the total output. And at the same approach, get like the function, this is capital, this is labor. We are going to differentiate the output with respect to capital and multiply by decay. Labor respect to capital, output with respect to labor, and multiply by what? Our DL. So this is how we are going to be, we can use it to also look at the total differential aspect as well, to find the marginal rate of substitution or the slope of the isoquant. So how do we find the slope of the isoquant, the marginal rate of substitution? We are trying to achieve this aim, this formula. We are trying to achieve this formula.
Doc, we don't see the screen any longer.
You don't see the screen?
No, yeah, I mean, what you are sharing.
Hey.
The screen wasn't showing.
Come again.
The screen is not showing.
The screen is not showing.
Off, yes. We don't see anything of the slide that you are showing to us.
Since when?
Oh, it has been there for some time.
As you are speaking, you couldn't see.
As you are trying to explain Asofat and the rest and whatever, and the labor,
but the calculation, you were seeing the screen.
Yes,
huh?
Yes, sir.
With the calculation, okay. So it means that when
just now you couldn't see.
Okay, so let me stop sharing and share again and see. Is it visible now?
No.
You can still see the screen.
Yeah, there is nothing showing, Doc.
Yeah, we are flickering, but still. Let's rejoin and see if it can work.
Or as already, I don't know how I'm going to do it because I'm showing it. I've not changed anything. That is how I started it. I don't know. Can you see? Can you see the slides now?
No, Doc.
Oh,
Sir,
Yeah.
Hey.
Hello. Hello.
Hi.
Hi.
Hello.
Can you see?
Yes, sir.
Okay.
Yes, you
Please,
can
would you
see
like
now.
to go for some? Would you like to go for some break?
Yes, sir.
Yes. So how long?
30 minutes is okay.
All right. So let's go for 30 minutes break and come. So we'll come exactly 10
10
o'clock.
o'clock.
Yes.
I was not for my sister Kakana and then see someone bit to me. Banchi. I go. So why for so I thought what can enough was about we are with the mention.
We see it usually. Now, for sure, I'm going to tell you. I'm going to tell you. I'm not sure what to say. I'm just going to be my back. That's no, I'm not professional. Then we don't know what I say.
Was say oh yeah.
Now, so I'm question Italian woman.
And I say oh yeah, ready. I want me or not so the way or bow why I meet me in Casa. I had one dress up. Or my pata, we no make it here. Yan family and why. On Baby Yagma. It's in your family and Catra.
Then I'm from
Make out a body. Body and I went to inform myself. You mean into two red in Catra. Why? Do I want to cast or into my castle? One and another makes sense. We are now to me, sorry. I mean, Yana can mother her. It is what me sorry, dear. 82 red in Catra. Ibrahim. Oh my. Oh my. Oh my. I said, ma, Mekai, whom you are, mammy. Brought to me, brought to me, brought to you. And I'm saying, now by at that point,
Papa me no futa some bantu so man no. E go ba so ni inside that woman. Say do na ma. Who say who? Who go to go na me na take na do na kama ma. So now balance my head one up. Come over there. Who be doing na sapa. Very that same number here. Also for some to that very who be that very. What is it for you are coming to the come to me. Ah, full level mu grab mu.
Eric, Eric,
Yes, sir.
Eric.
Yes,
What
sir.
is going on? I can't hear. What is going on? I can't hear anything now. Eric,
Yes,
I said I
sir.
can't hear anything. I can't hear anything. Is this for my end
We are
or
on
for?
break. We were on break. We were on break,
Ah,
so
okay,
we are yet to resume. Why you just joined?
okay. I joined and my network issues. I left. Okay.
Oh, okay, so you're on break. We will start very soon.
Okay, so welcome back. Let's do some application for total differential. Hello.
Hello, sir.
Yeah, so let's come back and let's continue from yes with the next 1 hour to be able to wrap up.
Okay.
Okay, so we are going to do an application with regards to our total differential, and we are going to start with our production function. We can apply, yes, in so many fields, even total cost theory, we can apply it. But let's concentrate on the production function, where the output that the firm produces can depend on two inputs, capital and labor. So if we are given capital and labor, we might want to find out the combination of these two inputs, capital and labor, that will give us a certain level of output. And that is what we call the asequant. So the asequant is just a curve or a slope showing the combination of different inputs that will yield the same level of output. So we use the marginal rate of technical substitution to measure the slope of the asequant. And the slope of asequant is given as M. The marginal rate of substitution is given as this. So we want to use the total differential in order to derive the slope of the asquant, or the slope of the production curve. Okay, so we start with the total differential. We know that when we are given two functions, two input, capital and labor, we can find the total differential. And this should be familiar with what we have just done. So we differentiate respect to the individual input, then you multiply by the small changes in the capital and the labor. So the first part will give you the total output, the total changes in capital. The second one will give you the total changes in labor. And how these two combinations, the total or the sum of this will change our output level. Okay, so with this, we can derive, we want to derive this, we want to come back to this, we want to use the total differential function or approach to derive the marginal rate of technical substitution. The marginal rate of technical substitution simply means the trade-off between capital and labor. And that also means that it is an opportunity cost for you to produce more of capital, then you have to sacrifice some level of labor and vice versa. So you cannot produce these things at their maximum at the same time. You need to do a trade-off. And what we use to describe trade-off is the marginal rate of technical substitution. So once we are able to define this, then we can equate, we can let this one cross the equal sign. The next one is that when we have this, we can say let the changes in capital or the changes in output should be equal to 0. So if the changes in capital is equal to 0, so we can equate, so the changes in output be equal to 0, so that we can get this condition here. Okay, so once we get this condition, we can send this one to the equal, across the equal sign to this place. So we can send it across the equal sign. So that is what we did for the next one. So this one will be there. Then we send this one to the equal sign. That is what we have here. Okay. Now our aim is to find decay over dl. Decay over dl. How are we going to do that? First, if you have something like this, I didn't want to use this one, but let me try and see. We have something like this. So we have something like this that we want to find the marginal rate of technical substitution. So once we say, when we put this change in output to be equal to 0, then we can now equate this one to 0. And then we move this one across the equal sign. So we have our decay, the output over the capital, and then multiply by the capital to be equal to. So this one will send this one to the equal sign. If it is positive, if we are sending it become negative, so negative the output over the L multiplied by our DL. So this is what we have. Okay. Remember that we want to find our decay over our DL. This is what we are going to do. So once we want to find this, first of all, let's divide both sides by the L. So we divide here by the L, and divide here by the L. so that this DL will cancel this DL. Okay. If you have that one, it means that the remaining one is the output over the K multiplied by the K, and this one is all divided by the L. And this is equal to what is remaining here is the output over the L. Now, I don't want this one to be there. I don't want the output over the K to be there. So I will divide this one divide here by the output, the K. And here too by the output, the K. So that this output decay will cancel this output decay. We'll cancel this. And then if you are able to do that, it means that we now have our remaining one. What is remaining is our decay over the L. So decay over the L. This is what remaining. And this is equal to the remaining one here is the output over the K, the output over the K, the output over the K. This is this one, okay, or the L, the output over the L. Sorry, the output over the L, and this is divided by the output over the K. Okay. Now, what is output over the K? This one, if we have the output over the L, it's the same as the marginal product of labor, MPL. And then the output over the K is the same as the marginal product of capital. So the output over the K is the same as the marginal product of capital. Okay. So if you are able to establish that, it means that the minus is also attached to them. Remember, this one was crossing the equal sign, so the minus is still attached to this. So at the end, we are going to get our decay over our DL to be equal to our marginal product of labor or capital over our marginal product of labor. And here is minus. Okay. So that is how we're able to get this. That is how we are able to get this. It's the same thing, the marginal product of labor, the marginal product of capital. So that is how we were able to get this one. First of all, you send this to the equal sign, then divide by the L. Then when you finish, you can cancel and then the second round, you divide by the L, the K, and you have the final answer. So this is how we use the total differential approach to find the marginal rate of substitution. So at the end, that is what we are going to get at the end. And like I explained, the marginal rate of substitution just shows the trade-off between capital and labor. For you to produce more of capital, then you need to sacrifice some level of labor. Let's say these are for your doing pleasure. So we have worked a lot of examples concerning the total differential. So when you, at your free time, you can try these exercises on your own using the total differential approach. Try to see whether you can differentiate them or not. Okay, so we are done with the total differential aspect and its application. let's move on to total derivatives. Total derivatives. What is total derivative? So far, we have been able to look at multivariate or the multiple variable functions that are independent variables, and those independent variables were independent. So we look at for example, output. Let me look the output. We say output is a function of capital and labor. Now, these two, with the total differential, we assume that capital and labor are independent. Even though they are independent variables, they are independent. They don't depend on anything. Okay, that is what we look at so far. But sometimes capital and labor may depend on other factors. Capital and labor may depend on other factors. So it means that once we have looked at them already, if we assume capital and labor is independent, it means they are not related to each other at all. And then we're able to look at functions that are independent, like this function, for instance, x1 and x2. We say they are independent. So if they are independent, they are not related to each other. Okay. But we can find, or we can look at some examples that in economics, in business, in finance, in sciences, that the independent variables are related. Okay. The independent variables are related. So we are going to look at a situation whereby the independent variables are related. In that case, we cannot use the total differential approach. The approach that we are going to use is what we call the total derivative. So the difference between the total derivative and the total differentiation is that with the total differentiation or differential, we can have functions that are related. The functions are independent, so the functions are independent but are unrelated. And then with the derivative, the functions are independent, but they are dependent on other factors. Okay. So what is total derivative? One example that we are going to look at is the quantity of output produced by a firm. And that is what I mentioned earlier on. But again, we all know that the output level produced by the firm is either dependent on capital or what? Labor. And we are going to also assume that, well, output depends on capital labor, but don't we think that labor also depends, and what to think that output, we're also going to assume that for the sake of simplicity, that we're going to also assume that our output that we produce also depends on time. Okay, so how long you have been producing or you have been in the system will give you a lot of experiences, and that will also influence the output you are going to produce. And because time can affect our technology, it will in turn affect our output. So through technology depends on time, and then output also depends on technology. So it means that time is a very good factor that will also influence output. What we are trying to communicate here is that apart from capital and labor, time also determines how much a firm produces goods and services. So time is another factor. Now, what about labor? It also tells you that the quantity of labor also uses some time, also depends on time. So we have assumed that output depends on time, and output also depends on labor. So we can say that our output now is a function of time and labor. The T here represent time, and then L here represent labor. For now, let's use unit value. Let's use the two, only the labor, and see how we are going to do it. We are assuming that output depend on the time level. Output also depend on what time. Okay, so take note of that. So apart from capital and labor, output also depend on our time level. So if we assume that output depend on labor and time, we also know that the quantity of labor that the firm uses also changes over time. So at least labor also depend on time. So labor depends on time. That is T. Remember initially that we said time output depend on labor and time. Now labor depend on time. So we can have the dynamics here. Output depend on labor and time. It's going to affect our Y directly. It will affect the Y directly. It also have an indirect impact on the output through time. Okay, through time. So through time can pass through labor before it can have an impact on the output. So changes in time have a direct and indirect impact on output. What the first one is direct output. The direct output means that it has to pass through directly to affect output. The indirect means that you have to pass through labor.
Hello. Hello.
Hello, man.
Hi.
Yeah.
Please, is it a
Hello.
network issue? Or
That's what I said.
is it a network issue?
Yeah, it might be network issue coming from a sales place.
Okay.
Please, can someone call him and let's find out? Are you guys there? Maybe if the course rep is around, he or she should kindly call him then. We'll know what is happening, please.
Hi, colleagues. Please, has anyone tried calling him? Because his line is not going through. I don't know, maybe if it's from my end. Someone can try and call him too. And let's see.
Yes, course rep.
Tina. Madam.
Yeah, course rep. I also tried, but it seems his number is very busy.
Then I guess it could be a network issue because even his line is not going through. So let's wait.
Let's wait a bit.
Yeah.
Hello, good morning. I've equally tried his line, but he's not answering.
Good morning.
We'll have to wait a bit. I tried his line.
Then we have a second class at 11 of microeconomics.
11:40, please.
11:40.
It's 11:40.
Yeah.
Okay.
But this course, it's like the course is hard. It's even difficult than the first one.
Yeah, you are on record, so.
Oh yeah, that's. I'm not criticizing anyone. I'm only saying the course is difficult. It's not that I'm attacking someone.
You are attacking the course.
This is mathematics 2, okay?
More than appetite. More than
Sorry, sir.
more than appetite. Hey.
It's where we'll try our best.
Somebody.
Ellen, are you there? Hi, Ellen.
I'm here. Hello, Florence.
How is this Masu treating you?
Very well,
This
very well. In fact, she has grabbed everything. She even called me
Thank
saying
God.
that, oh, this one is very easy as
Yeah,
compared to the mathematics one.
yeah.
Really?
Ellen, you say it's very cheap.
Very, very cheap.
I
Oh
know.
wow. Nice. Please, tonight we'll have a discussion. We'll come back. You teach us.
Don't mind Tina. She's just finding problems for Ellen. Ellen hasn't said anything, but she's just finding problems for her.
That reminds me. The results. How are they releasing it? And we are see some are having two courses. I don't.
I wanted to even ask for Mr. Audi about the
Because
first
I don't know of two
mathematics, but I
people,
want
but
him to finish with it.
because when you go to the portal and click on check IC, you realize that they will tell you that mathematics for economics one quiz, one isn't captured.
Some more.
So I think the institution is aware. They are aware of it. Oh, because
Maybe
it's for all
something
of us,
that
not
connect
only
us to
one
our
person.
faith. Okay.
They are aware.
This is a coma school there. Yoko people can't even arrest it.
Shall we go?
You have to try to arrest it yourself.
And you need people for understand that we want the betterment for Ghana, not that they should come and arrest us. So Ghana
Inside
food
the
in
summer,
sorry.
I did.
Ghana food in sorry.
They have students, they are complaining bitterly about their results.
Did they also do economics?
No, they don't do economics. Like at English. Those offering English language.
Oh, okay. Oh, okay. Mr. Udu has to tell us something at the end of this list.
Yeah, he has to tell her whether we perform the paper or not. That one is it.
Now you yourself, when we were writing it,
Even your
didn't you know
quizzes were
that
not
you
captured.
will
You
perform?
want to know how much you performed. You
Quiz
rewrite
one
the
was
quizzes again.
it's like quiz two. We didn't see that one too, or they release and I didn't check. I can't remember.
Quiz 2 came. Quiz 2 came. They
I
released
Pius,
quiz
don't
2.
I
know.
saw a score.
It's only
Pius,
quiz 1 that we didn't see.
Pius,
Yes.
I saw your grade.
I better calm down. Which one you saw my grade? No
Oh,
expose
I saw
man.
it. Oh,
You want me to stop joining class?
You make man shiver. You
Ah,
saw what we man
if
do.
yeah.
you want to just do that?
You were fighting for A plus. After all fighting for A plus, you got only A.
I mean, it's like their grade system. But see, I fought you like that.
You see your level.
Mr. Archibald.
You see your level.
So the other departments have they released or it's also like ours 3 courses?
They
For them,
got two.
they've released only one
Two.
English. Social studies,
Geography
only one.
Geography 2.
The geography they released 2 for them.
2, yeah.
The geography people, they say, yeah.
Instead to ask the economic students to turn up and say, Ghana, no story. No story there.
Don't worry, they will release it to everyone. They will release everything. It's only see the way forward. That's all.
Ghana for sorry, you know what in a
No story there. You want the economists to start. You want the economists to stand up for us. Not Ghana for.
Ghana economists, Baumia and them things, them should stand up for us.
It's not easy for Harvard students to how much more UCC.
This one cry, you don't teach at the secondary school. I don't know why you're doing it.
This economist, I don't know why I now this unnecessary thing.
So is that the one that is that the one Baumia lent?
No, that's the one. He's not in America.
Baumia and Atofosing lent all these. That's why they are doing the thing for them.
Yeah, don't be surprised by next year. Some of you will appear on national television, your economists, and start telling lies.
Hey,
Mr. Pius,
now what I will do?
See, you people, you sit on television and say the fiscal policy.
You are the number one. You are the number one to tell the lies. You be the first person to tell the lies.
Me, I'll be economic analysis. I'll be economic analysis.
Then
I'll
you
do
now
analysis.
Wow.
then you now start
Then
messing.
let the math work. Let your math work.
Then
So
you
they
think
can
all
make good
these
analysis.
Start
as a Thomas.
calculating differential.
I will tell you how the city is performing. Don't worry. Per the dollar rate. I'll tell you. Don't worry.
When you see someone putting economic figures, you are always happy until you start reading the pause and you know that it's not easy.
It's
Not
easy.
easy,
Good.
mind you.
Ah,
But I
just
think
because
if
you
we were
quote
to
it.
go for a face-to-face, it would have been easier. This is online. That's
Even
why
the
we are
first
finding it difficult to understand.
Oh, it's the same thing, madam.
Oh, maybe who
Everything
they
it's
is
just
can
the
get
same
back,
thing.
okay, but can't hear more.
No,
Just
the
because you
figures
quote
would
it
have been
pages.
better. Because
You know, the thing is that it's a normal
writing
thing.
on
When
the
you are
board
school,
price is something else.
the thing is that it's even normal. Every semester there will be a call that will bully you. It's normal. So let's just take it like that. Maybe this is a call that will
But
bully us.
It cuts
but
across.
this
So
one
even the
different.
English people to the same, they complain. The social studies to the same. They have a course that
Complain.
they are complaining
It's
about.
a problem.
Go to our so our water
No, when you
pollution.
are to take people through online mathematics like this, you have to do it step by step. Sometimes you work and have to clean and confuse the whole place. It's
That is
not
the
helping
problem.
matters.
That is the problem.
Okay, I'll check the course for you. You go and learn Ottomas North Africa in social studies.
I be that
Last
one is
semester
all
they were
about.
complaining bitterly about the Ottoman
Ottoman
North America.
North Africa. Yeah, I don't know. You gotta say North Africa.
By those
The
who
social
by
studies
those who
were
are slagging
complaining.
because social studies like they are learning all the courses. They will go and learn geography, learn economics. At the end, they will award them social studies.
Best social is
It's a cheat.
integrated.
They were still teaching economics.
Yeah.
No, they were not teaching.
Methods of teaching economics. So I was now
No,
wondering.
they do
They were
they
not
do
teaching
macro.
economics.
They do
They were
macro.
doing social
Or
studies.
they were doing. No, one of them they
Yeah.
did it. Either teaching economics or methods of teaching economics. They did one.
No,
They did teaching economics. So
they did not.
Yes, they did
They I did it.
teach
One guy
teaching
at
teach
the
economics.
economics.
Teaching economics, yeah,
I had
teaching,
one guy
yeah,
at my
that's
They
it.
did teaching economics. Yes, that was the last paper we had with them.
They did it. A
They did.
Yeah,
colleague of
true,
mine,
true.
he's doing one of the courses.
Yeah,
So
they
They
did.
maybe
I
did
thought
next.
you were
my
talking about the
they
method.
they even did macro.
Yes, they also did
And this is
macro.
actually they be doing teaching social studies. So
They
they
didn't.
give the
They
economics at
rather
the same time.
social studies.
Mm-hmm. UCC and integration there.
So maybe next time I study my learner.
Next semester, you people will also do social
Why
studies.
geography students are doing some are doing 3, we are doing 4 this semester. This block. People are doing 3, only 3
Geography is
courses.
not.
3.
Geography is not difficult. That's why.
They are doing 3, we are doing 4.
Geography is not difficult. That's why.
Who says it's not difficult?
Geography, are you the same?
Ask Mighty what is happening. Oh no, Mighty is not doing. Ask those who are doing geography, cartography, survey, and the rest.
You go and
We are
try.
also doing 5 this semester. Political science. Yeah.
I got political science. I do balance. Separation of powers. Or
Separation of the.
I learned a time I'm doing mathematics with
Separation of
econs
powers.
or math with economics.
And those people, I've not met one who's doing accounts with math.
I like one person is doing it too. Mathematics with economics.
Nobody is doing it.
Eh.
I learned those.
So all of you,
Those who started didn't perform well. So this our time. They didn't allow anyone to choose it. And they
Hey,
said they
that
want to
program
set a
there.
lecture for them. It's very difficult.
Ecomas.
Econs with mathematics there.
It was sweet too.
Hello.
Who said it's sweet?
Sir, welcome back.
Say you're welcome.
Hello.
Hello, sir.
How long have you been off?
I welcome back.
45 minutes. 40 minutes.
How
Oh,
long
it's
have you
been
talked?
30 minutes.
it's up to
About
20 minutes. I even give you
we have called you, but
20 minutes.
Yes.
you were not picking.
Hey. So
We
where
have
where
called
did
you
I
severally.
you called
So,
me?
so what you talking, sir?
Yes.
Yes, but you were not picking.
Oh. So where do we stop? Is it here? Oh. So where do we stop?
So you were explaining the labor and time.
Yeah, the labor and the capital.
Yeah, that's what you were explaining.
The time and labor.
Yeah.
Okay. So I was explaining that if we have our output that depend on two input, capital and labor, we know that capital and labor affect our output. But then output also depend on time. So there's a situation whereby we can have time as another input that also determine our output. So that's what I was explaining. But then we also say that sometimes our capital also depend on time, and then labor too also depend on time. So if that is the case, we will have a direct impact of capital labor on output, and we also have indirect impact where time has to pass through capital and labor and eventually passes through our output. So capital output depend on time, depend on capital, depend on labor. Once labor and capital also depend on time. Okay, so first we'll look at only one input. That is, let's say our output is dependent on only labor and time. So this can affect our output. Time also can affect our output. But sometimes we are saying that sometimes the quantity of labor also depend on time. So if that is the case, it means that labor can affect output directly. Time can also affect output directly. And then time can also affect output through labor. And that will give you the indirect impact, or the indirect that we are talking about. So time has two impacts on output. We have the direct impact and the indirect impact. So we go to this function. Yes, this one, like I explained, that this is our output, this is our labor, this is our time. We can see that time can have a direct output from here to here, can be a direct output. And then time can pass through labor before it can have an impact on our output. This is the indirect output that we are talking about. Okay, so if we have this kind of situation, we cannot use the total differential. The only thing that we are going to use is the total derivative. So the total derivative will help us differentiate with respect to time. So if we are going to do that, let's see that we have our output Y, which is dependent on our labor and our time. And we also know that our labor is dependent on our time. Labor is dependent on time. So if you are going to use the total derivative to differentiate this one, so what we are going to do is, first, we are going to differentiate the output with respect to our labor, and also differentiate our output with respect to our time. So our time. Then you differentiate the labor, which is this one, with respect to our time. Then you add them together, and that will give us our total derivative. Our total derivative. Okay, so here, what you simply need to do is that, first, let's differentiate our output with respect to labor. So you have, this is a function, so you differentiate the function. So you have the F, which is the function, over our labor, the L. The L. Then you see that the L here, the labor here, is a function of time. It's a function of time. So you have to differentiate the labor with respect to time. So you have to multiply this one by dl over time. And then you now add this one plus. Now, you now come and differentiate output with respect to our time. So we have our df with respect to time. Then you multiply this one, time dependent on itself. So you differentiate this one, dt over dt. Dt over dt. So that this dt here can cancel dt here. And at the end, we are going to get a sample model. We are going to get a sample model. We are going to get a sample model like this. While this dt is canceling the dt, the only one left is going to be our dt, our df multiplied over dl, which is the first one, df dl multiplied by dl dt. This is the first one that we have, plus df dt, because the dt was cancelled out. What is left is, so this one was taken off with this. So what is left is our df over dt. So this is how we use the total differential or total derivative approach. When we get to more examples, then we'll look at them as well. Now, let's look at a situation whereby you have more than one capital. So here we are looking at capital, labor, and time, 3 variables. And here again, capital depend on time, labor depend on time. So we have like 5. We have like 5. Capital dependent on time, labor dependent on time, and output also dependent on capital, labor, and time. So it means that those functions, this function here, has a direct impact on output, and then time also have an indirect impact on what? Output through the labor and capital. So let's look at that quickly. Okay, so with this, okay, so with this, let's move on to have our, so here we have capital. So our y here, let me write them here. Y is a function of capital, labor, and time. And then capital is a function of what? Time. Labor is a function of time. So in this sense, we cannot use the total differential. We are going to use the total derivative. So what we are going to do is that let's differentiate respect to capital, differentiate respect to labor and time, and see. So we are going to look at change in the z over change in the y over time. Over time. This one first, we differentiate respect to capital first. So we have our decay, no, the function. Let's use the f over decay. Over decay. Then we multiply that one by k. K depend on time, right? So we also differentiate our decay over time. Plus, now we differentiate our y respect to time labor. So the function, the f over our L. Then labor is also a function of time. So we multiply by the L over the T. Then plus, now output is dependent on time. So we have our the function, we differentiate the function over time, respect to time. Respect to time over the T. Then we multiply it by the first, we differentiate time with respect to itself, time by itself. Time by itself. So you see how we did the differentiation. So if you take capital, you have to multiply the capital by time, the differential with respect to time. If you take labor, you multiply it by labor. And if you take time, you also multiply it by time. Okay, so if you do that, we can see that this is the T. This is also the T. It's going to cancel off. So what is going to be left is this approach, this one. This is what is going to be left. And that is what you can see here. This is the first part. But because the T are equal, we can cancel this one and cancel this, so that the remaining one is this here. So last part, this is also what we have here. So this is how we do the total derivatives. So let's see whether you can get examples. Yes, so there's some few examples here. So let's look at this example. So here we are going to find the total derivative or the total derivative respect to time. So what we do is that you can see that here x is a function, y is a function of x and y, and y is a function of x, but the x has no function. X has no function. So x is a function of 0. So we don't even consider x again. So what we are going to do is that let's look at the changes in let's look at the total derivatives. So we differentiate this one with respect to our time or our first variable x. So we have our the function here with respect to x. Then we're supposed to multiply this one by a function of x that depends on another variable. But here, x is not dependent on anything. So x is 0. So we leave it like that. So plus, let's move to the other variable, z respect to y.
Hello, sir.
So
Your
we have
screen
a
is
function
off.
of.
Liz, your screen is off.
Because this is simply what we are doing. So you get differentiate this one and differentiate them and substitute them into the formula. That's all about the total derivative. Total derivative. So here, what you need to do is that. Hello?
Hello, sir. The screen.
That's all right,
The
sir.
screen.
That's it. That's finish.
Mr. Mohammed, please. What is problem? Mr. Mohammed.
Slide dock has dropped too.
Well, you say what?
Today the network isn't stable like that.
Hello? Hello, can you hear me?
Yes.
Yeah, so I think we have to stop here then meet maybe probably next week. Any consent?
Oh, okay. I do.
All right, thank you very much, Doc.
Yeah.
We appreciate
But
for
Doc, if we
teaching.
can have the slides so that we can read through.
You don't have the slides?
Yes, we don't.
Oh, okay. I will send the slides to who's your course rep?
The network is misbehaving, bro.
Yeah, who's your course rep?
Course rep.
Who's it? Wasn't
You
that
don't have a course rep. We can elect one. Or you have a course rep?
Yes, Florence. Florence.
Who's the course rep? So the course rep can contact me for the slides. Oh, okay. I'm on your page now. I'll drop it on your page.
Thank you, Doc.
Okay. All right. Please, Doc.
Yeah.
Doc, I want to ask something.
Yeah, go ahead.
We wanted to find out our last services course. They are yet to release the results. One is.
You want to find out about what?
The mathematics for the one we did last semester.
Yeah.
It's like yes, they are yet to release the result. Now, we are told that this one isn't captured yet.
Quiz 1 is not captured.
Yes, please.
And what is that quiz 1?
Sorry, I'm not getting you, Doc.
They said quiz 1 is not captured yet.
Yes, please.
Okay.
So we wanted to find out whether it's from your end or the university.
Okay, don't worry. I'll find out on Monday.
Okay, sir.
I'll let you guys did several quizzes, or?
Yes, we always do quiz 1 and quiz 2.
You did quiz 1 and quiz 2.
So write the quiz 1 before end of semester.
No, last semester you did quiz. How many quizzes?
2. Quiz 1 and 2.
We did 2 with an assignment and
You
then
did
end
quiz
of
1 and quiz
semester.
2, and then assignment.
Yeah,
Yes,
and then
please.
the end of semester.
Okay. Okay. So I'll find out.
Okay, sir.
All right.
Thank you.
Enjoy your holiday. Yes.
Say, are we done though?
Yeah, we are
Yeah.
done.
So
Same to you,
we are
sir.
going to continue next week.
Oh, okay.
We really miss you. You're
But last
Please,
semester
welcome.
we
the slides, don't forget, please.
Hello, sir. Hello, sir.
Yeah.
Please, can we get some reading material apart from the slide? Can we get some books?
Okay. Okay. I'll share with you.
Okay, sir. Thank you.
The derivative,
All right.
didn't finish.
Enjoy your holidays.
Same to you, Doc.
At the LMS is 11 or 11:30. Yeah, Ima.
But I know. Hello.
Yeah, I can hear you.
But he did not finish what he was doing. Or
Who? Is it Doc?
yeah.
The thing is that because we don't have the slides, I can't tell whether we're done or not. But it's like he was done with that question.
The network went off during that time.
Okay, so you let's prepare for 11:40 class then. Maybe there is from next week. I think you will address that today.
Okay.
Hello, Isaac.
Okay.
Isaac.
Yo.
Isaac.
Yo.
Isaac.
Yo, bro.
Yeah.
Yo, doggy. Yo, bro.
Vanessa is not here. I wanted
Oh, please. Hello, guys.
Yes.
Sorry, my end was little noisy. That's why I didn't respond when you were asking for course ref. Please, can we select a different course ref?
Why
Oh,
are
you
you
do it. You do it.
why
You do it.
are you
No,
that?
we will not select any course rope.
You do it by force.
Do it.
Why a first one, second
Oh,
one,
oh,
one
oh.
and two. So you do it.
You do it for the whole year. Do it.
You do it. And even next time.
You do till you finish.
Next year,
And
bro,
even next
you
time,
do
you do
it. Masters.
Even in masters, yeah.
when we are going for graduation, you do it again.
Yes, she finish it over there.
No. Let's give it to Tina. She's
No,
very
no,
good.
no,
You are
no.
seeing your way. Me,
No,
you
you do it.
Oh,
Do
I'm
it.
serious. Let's select a new course, please.
Oh, you do it.
Please.
You do it.
Can
We
you
too,
give
we
us
are
5
serious.
reasons why you don't want to course?
Yeah.
With even
A
illustration.
typical example. Did you hear the sound?
Yes.
When you were even asking me, I couldn't respond because of those
We are
sounds.
not hearing any sound.
So don't worry. We like it like that. It's okay. We
I
are
like
okay with that.
such sounds. Even I like such sounds, so that's good.
You people,
Continue
then
to
I
do
think
it. We love you. We love you. We love you. Continue to
hey
Masters 2, you do it, eh? Masters 2,
Where,
you do
where,
Chumesi.
it.
where, where MPP say we are moving forward, no, you thought it was a joke. You will handle the
Hey.
cost.
Okay, so we meet at 11:40, right?
Yeah.
All
All
right
right.
then. See you.
Okay. Right. Mr. Menu. Hello, Mr. Menu.
Hello.
Hey,
Hello.
today I didn't hear from you.
Hello.
It's the long I heard from you.
Play, who is this?
Hey, Ima Chumesi.
Okay. Oh.
Oh, I see. No, easy. We have started again.
Oh, you see now.
You say?
This time we have to start early. Oh.
Yeah, it's true. It's true, fine. You have to start telephone.
Have to start early.
Mm-hmm.
This time I'll look for some of the books and print and sit up.
Oh, okay.
Especially the mathematics.
Yeah. How was the three paper they released? Was it okay?
Yeah, they were okay.
Oh, thank God. Thank God. We have more to do. This mathematics. The problem is because like the major problem is the board. Okay, when he's writing on the
it's
board,
too small.
because it's narrow, you can't see, you can't get it. That is the only problem. So if it should
They
have
should have
been
structured in such a way that at least we meet once for summary so that the lecturer will take time to take us through, especially the calculation section. Look at what happened to the geography.
yes.
The man reading and interpretation. We can't
Yeah.
see anything even to
But the course rep asked us to report. I don't know whether you did it.
we did and give it to the coordinator at the center.
Oh, okay. Okay, reach our place. So I write a letter and send to the course rep to be sent to the doctor.
Okay. I think
But I'm
it is not
today.
the doctor's fault. Too. It was a fault of the examiners, those who did the printing.
Oh, I see.
They did the photocopy, or they should have even done colored photocopy or provide triple sheets.
That paper they shouldn't fail anyone because you did not say anything.
So we are meeting doctor at 11:30.
I learned 11:40.
Hey, thank you.
So, Mr. Bino, this time we should start the math. We should put our mind together so we can do something for ourselves.
So where are you located?
Oh, I'm at Sudru. Yeah, I'm going to Winnipeg Central Region.
Okay.
Yeah.
I'm in Sunyane Center.
Oh, okay. So you and this guy was there. What do you call it? You and Ellen and
Yes.
Obin.
Yeah, Ellen.
Oh, okay. And Obin was there, but and now Ellen now he has left to Kumasi.
Yeah, he has relocated to Kumasi.
Oh, okay. So for my place there, I'm the only one.
Oh, we are three now.
My place there. It's not easy over there.
That's much more. It shall be. We are almost in the middle of the program.
Yeah. We pray that the other results, everything will go well.
We are praying.
At least we get our pass mark and we go. The way the English people they are complaining, English their results are not good at all.
It's not easy. English is not easy.
They normally say the literature that they have been doing, they will give them literature books, but they will set on different books. That's their problem. I nearly read English. And I stopped. So English there is not easy.
So let's pray that by the end of this vlog, everything will be full for us.
It's not easy. The cons there is okay. The only problem is the mathematics. Nah.
But I think this is the last part. If we're able to sail
Okay.
through this one, that is all.
Okay. Oh, so the next blog, you're not going to do mathematics.
So this will be the end.
After Mr. Tre, there will not be anything like mathematics.
No.
Oh,
This is the last one.
And God should help us. Okay. How you communicate? Communicate. So the my side there, the mathematics, those who operate mathematics, if I don't know if our group we all agree and make maybe after maybe we find a date and do group the discussion about the mathematics, because those who are offering math and that's what they have been doing.
Okay.
So after everything they learn, they find days and they meet and discuss what they are doing. So it is helping them.
Really, it's not bad.
The math department, please, it's helping them. At times they hide another math teacher, maybe from an institution. So they pay them, they contribute an amount of money, and then they give to that person, and the person will be teaching them. And it's helping them. It's like a past student. Those who joined the course and completed last year.
Okay.
So it is helping them. So if you could also get maybe someone who completed this same course last year, but the person did well, the person, or any tutor, or even any of us, because math today you have to do more of discussion.
So you see the importance of.
You have to do more of discussion to help you.
We are sure that we do know. So we'll be a FMU. Oh, is that bad? Oh, sorry. So that's in front. Okay, Chumasi, so let's talk this time.
Okay, yeah, well.
So if anything, we can be sharing ideas.
Okay, go. Yeah.
All right.
Okay. Bye.
Kita nyipe hilo. Hello, Abdamani. Hello. Hello. Hello, Abdulrahman.
Yes, sir.
Hello. Good
Hello.
morning.
Good morning. Please, how are you?
I'm doing well.
Yeah.
Please,
I
is that
just,
the link for economics, macroeconomics?
yeah, I'm even searching for it.
This is not the link. This one is for the one that we just ended, mathematics. So leave here.
Okay. 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 Thank you
Are
very
you on the
much.
page? Are you on the
Yeah, I
page?
was. Yeah, I'm not.
Go
So I'll
back.
go there.
Go back to the page. They've kept a new link there.
Okay. Okay. Thank you, sir. Uh. Okay. Uh,
Abdul,
Sir.
Abdul Ibrahim.
Sir.
Yeah, good morning, my brother.
Good morning.
That's Kupuku. My phone went off.
Okay.
So later part of the discussion, I did not get anything. So
I do.
can you tell me exactly what he ended
Oh,
with?
we were still calculating on it, but still, I'll get contacting you.
You get what for me? Hello, can you hear me? Hello. Abdulman. Abdulman. Hello.